Crohn's disease is a chronic inflammatory condition of the gastrointestinal tract. It is more prevalent among adolescents and young adults between the ages of 15 and 35, and boys under 16 seem to be at higher risk of Crohn's, although the risk for females increases in older age. The cause of Crohn's disease are not well understood. Diet and stress may aggravate Crohn's, but do not cause the disease on their own. Research suggests hereditary, genetics, and/or environmental factors to contribute to the development of Crohn's disease. The GI tract normally contains harmless bacteria, many of which help in digestion. The immune system usually attacks and kills foreign invaders such as bacteria, viruses, fungi, and other microorganisms. And under normal circumstances, the harmless bacteria in the intestines are protected from such an attack. In patients with Crohn's disease, defects in the first-line defense mechanism, such as disrupted epithelial and mucosal barrier function, contribute to the increased bacterial penetration. Defects in the NOD2 and CARD9 genes that are involved in pattern recognition lead to the increased response of antigen-presenting cells to commensal microbes. NOD2 and CARD9 receptors can be found within the cytoplasm of cells. When these receptors come into contact with bacteria from the gut, they are activated via pathogen-associated molecular patterns from the murmyl dipeptide, MDP. MDP is the building block of peptidoglycan, which forms the majority of bacterial cell walls. Because of this, the NF-kappa B cascade is activated, which leads to the production of pro-inflammatory cytokines like TNF-alpha and IL-6. Dendritic cells sample the gut microbiota. When bacteria comes into contact with TLR4 on dendritic cells, the activated dendritic cell will travel to the mesenteric lymph nodes. Here, they will stimulate naive T cells to differentiate into affected T cell subtypes depending on the cytokines that are present. Th1 cells, after activation, will lead to the production of pro-inflammatory cytokines through the activation of the NF-kappa B pathway. Th17 cells are activated through the IL-23 receptor, which in turn activates the JAK-STAT-TYK pathway that enhances pro-inflammatory cytokine production, for example, IL-17 and IL-21. T regulatory cells downregulate the immune system by producing anti-inflammatory cytokines such as IL-10, and this can inhibit Th17. Another major contribution to Crohn's pathogenesis comes from autophagy. In autophagosomes, intracellular components, including phagocytosed microbes, are degraded, after which their antigens are presented to CD4 cells. Autophagy is at least partly regulated by Crohn's risk alleles, such as ATG16L1, IRGM, and VAMP3. The activation of CD4 cells leads to the production of pro-inflammatory cytokines and the maintenance of the inflammation. All the displayed processes could finally lead to the homing of leukocytes to inflammational sites via the ICAM1 and ICAM3 adhesion molecules, and eventually neutrophil recruitment. Neutrophils, when activated, release various tissue-degrading compounds into the extracellular space. The most important of these chemicals are the lysosomal enzymes, myeloperoxidase, and elastase. Consequently, chronic inflammation, ulceration, and deeper microbial penetration will occur. TNF-alpha is a cytokine released by activated T cells and macrophages to defend the host against pathogens. It promotes an inflammatory response by stimulating the recruitment, differentiation, and activation of macrophages and neutrophils. It does this by increasing the production of pro-inflammatory cytokines, the permeability of the endothelial layer, and the expression of adhesion molecules. Higher TNF-alpha concentrations were found in the serum and stool samples of Crohn's disease patients, as well as an increased number of TNF-alpha producing cells in their intestinal biopsies.